Hello and welcome to a little video on genetics for the color of this horse's baby. And that horse happens to be named Dutchess, and she lives at this stable right here. Well, it's not right here, it's in upstate New York. Alright, so that horse, Dutchess, is right here with a past baby, but that's irrelevant. She has been bred with this horse right here, Sierra's All the Gold, who is at stud for Painted Bar Stables, the same stable Dutchess is at. Anyways, so here we have some genetic letters telling us the color of these horses. I'll get into it all later, but that's what it is if you're interested. Alright, so that horse plus that horse, what color does it make? Obviously this color, right? I mean, like, look, right there. This same color. It's gotta be that color. It's always gonna be that color, right? Right? No. Not always. Because following that logic, this horse was also at Painted Bar Stables, and Sierra would make that color horse, right? Wrong. Alright. Crystal and Sierra have made these two babies in the past. And one looks like this horse, the other looks like that. But, they're a mix of the two, right? Yeah, so it's called phenotype. That is the physical representation of genes. So, phenotype, this one looks more like her mother. Phenotype, this guy looks more like his father. However, genotype, their genes, they're a mix of the two. So, it's not always as straightforward as it seems. So, you might hear me, from now on, use the words heterozygous or homozygous. So, heterozygous means you have two different genes. Not different genes as in like height and hair length. It's genes as in this dominant gene is a black base, while the recessive gene is a red base. Homozygous is when you have two of the same, which can also be this two capital B's, which would be that color horse still. Because dominant genes always show up, whether they're homozygous or heterozygous. Big B's, or dominant genes, are kind of like the bullies. They'll just like step on this little bee and crush it right out of existence. It doesn't matter, except to the babies, of course. But, yes, so it doesn't matter anymore, because this horse is just the representation of this color. This one doesn't exist. Nope. Step on it. Alright, but these guys here can't be stepped on because there's no big bee to be stepping on them. Doesn't happen. And, yes, wrong button. These guys can't step on each other. That's not how stepping on things works. That's not how feet work either. Don't try to step on someone like that. You'll hurt yourself. Alright, so that is dominant and heterozygous and homozygous. If you need to remember hetero, think heterosexual. Different. Homosexual, the same. So, yeah. Now, the bases are the basic, obviously, colors a horse can be. All horses have these genes. Obviously. You can't not have a base. If I build a building without so every building has a base. If I build a building without a base, it's just going to fall over. Actually, it won't stand up in the first place. It can't exist. So, the black bases are called black horses. Whoa, I know. Black and black. Never would have guessed. Whoa. Now, a red base can be called chestnut, most commonly, or in some places they call it sorrel. Don't know why. Isn't sorrel a type of grass? I've got no idea. Alright, so black bases can either be these guys or these guys, because you've got the big B's. This little bee doesn't exist, remember? It's been stepped on. But a red base can only be this. It can't be heterozygous, because it's recessive, right? Now, why is red base not written like that? Or like this even, right? These are R's, by the way. So, red bases are not written like this because that's a different kind of gene. It is no longer, these two no longer correspond if they're written like this. And I've just scribbled all over the screen. Hope you can understand that. Alright, so, Punnett squares, see me use them. You might remember them from your biology class when you went over these stupid freaking pea pods. Yeah, pea pods, Gregor Mendel and his flowers and stuff. I'm not going to go over that again right now. Okay, so we're going to calculate the base color for the full of Sierra and Dutchess. Those are the two we were talking about earlier who are both really pale looking. That would make a pale baby, right? No, wrong. Alright, well, maybe right. I don't know yet. She hasn't had the baby. Alright, so we know that Sierra, who is a Perlino, is a black base. But now is he heterozygous or homozygous? Well, he's been tested for color, so we know he's heterozygous. Now Dutchess is a palomino, meaning she has a red base and thus can only be 2 recessive genes, or homozygous. So, I'm just going to do a Punnett square. I'm not going to explain it because I'm lazy. So we're going to have these possible combinations, meaning the baby has a 50% chance of being heterozygous, a black base, or a 50% chance of being homozygous, red base. So the next gene that adds on top of the base is called a agouti. It's what makes bay horses. Bay horses are like the dark brown with the black mane and tail and legs. So, because Sierra is a Perlino, oh, that is the wrong button, sorry, is a Perlino, we know that he has at least one agouti gene. Now, like I said, he's been tested, and we know he's heterozygous agouti. Now, Dutchess, we've got absolutely no idea because she is a palomino, and agouti genes do not affect red bases. So, for this one, you notice I've got V1 up here. We're going to pretend she's homozygous dominant. So now, I'm going to do the Punnett square very quickly. Sorry about my handwriting. It sucks normally. And now I'm writing on a computer screen and it's not doing my handwriting any justice. So, the baby will have a 50% chance of being homozygous dominant. That A is really funny looking. Alright, and a 50% chance of being heterozygous dominant. But, wait, this is the same color, right? Because this one doesn't exist. Right, so this is the genotype up here. This is the genotype. Phenotype, the baby, if it is a black base, would be 100% bay. Like, no matter what, that horse is going to be bay. Unless it has a red base, of course. So now in this next scenario, version 2, Sierra is still heterozygous. He is always going to be heterozygous, because we know what he is. Now let's pretend Dutchess is also heterozygous. We're going to come through, do our little Punnett square. I keep hitting the wrong button with my hand, I'm sorry. Touchscreen computers are really annoying. But sometimes they're handy. Only sometimes, though. And this is an A right there. It's not chlorine. Huh, chemistry jokes. Huh, no, okay. Alright. So now, this baby has a 25% chance of being homozygous dominant, a 50% chance of being heterozygous dominant, and a 25% chance of being heterozygous recessive. Phenotype-wise, pony has a 75% chance. Pony does not mean baby horse, by the way. 75% chance of having the bay, if it's a black base, and a 25% chance of not being bay, because that's the recessive, right? That's narrow there. Because that will not show up. So now in this next scenario, this is the last agouti, I promise. Alright, Sierra's still heterozygous. And we're going to pretend Dutchess is homozygous recessive. So now, I'm going to run through, do our Punnett square. the baby is 50% chance, there's a 0 there, 50% chance of being heterozygous dominant, 50% chance of being homozygous recessive. I don't even know why I'm saying homozygous recessive, because if it's recessive, it's recessive. It doesn't matter that it's homozygous. If it's heterozygous, it's dominant. In other words, 50% chance of being bay, and a 50% chance of being not. And my pen is spazzing out right now. I'm sorry. Alright, so now, cream gene. Whew. 5 minutes. Cream gene is technically written like this, but for time, I am just writing a C. So, being a Perlino, Sierra is 2 dominant. Being a Palomino, Dutchess is heterozygous. So now, I'm going to do this real quick. That's the wrong color. Oops. And that's supposed to be capital. So that means the baby is 50% chance of having 2 cream genes and a 50% chance of being, or of having 1 cream gene. So I'll talk more about that later. Now, oh no, my mic is falling off. Okay. Sorry, that would have been quite bad if it had. Alright, Tobiano, also known as a paint gene, is, well, we know Sierra is heterozygous because he has had solid babies, and then Dutchess is homozygous recessive because she has only had, well, she's a paint horse, but she does not have any paint genes because she's solid. So, let's run through this real quick. I might just divide this up into 2 parts because I don't think I can make it through. Fun. Alright, so, here we go. That means the baby has a 50% chance. Come on, you can do it, pen! You can do it! 50% chance of being heterozygous, and a 50% chance of being homozygous recessive. So, genotype, 50% chance of having paint markings, and a 50% chance of being solid. Oh, come on, pen. You can do that. You can do it. There you go. So, what affects what? Like, I just done all these calculations. Like, what? So confused. I skipped a page. Alright, so, when you have a black base, remember that's the, I'm going to change colors actually. That's the B, or the B. But that doesn't exist because it's been stepped on. New. Alright, so Agouti effects, because it makes the horse bay. The cream lanes, if you have 1, you get a smoky cream. Or, not a smoky cream, a smoky black. That says smoky, by the way. If you have 2, you get, smoky cream. There we go. So both of them are smoky, basically. Tobiano effects, it just gives them paint markings. You know. Alright, so if you've got a red base, you know, that's the homozygous recessive. Agouti does not affect the red base at all. So it doesn't matter. Agouti has been stepped on, so to speak. Don't twist your leg like that. It'd probably be very painful. Agouti has been stepped on. Why can I not draw my leg? There we go. It has been stepped on. It doesn't work in this situation. Cream effects, though, it lightens. If you have 1, you get a Palomino like Dutchess. If you have 2, you get a Cremello. Tobiano effects, it makes your horse a paint. Alright, this has been simply the calculation portion of this little genetics video. I will be doing the what can the baby actually be in like 5 seconds here. Thanks.